All right, class, hello. Welcome to Business Calculus. I hope you're going to have a lot of fun this semester and learn a lot. And we're going to get started right away. So section 1.1 is talking about limits and continuity. Whatever that might be, we'll find out in just a minute. So throughout the semester, we are going to deal a lot with the idea of functions. And we're going to explore functions. We're going to find derivatives of functions. Just in next section, right away, we're going to talk about something called the derivative of a function. We'll take the antiderivative of a function, and then we'll see how these two new ideas about functions help solve a lot of problems in economics. So they have a lot of applications. So which is why, since we're going to be talking so much about functions, I decided that it might be a good idea, even though you did take college algebra before coming here, which was just filled with talks about functions, that we reviewed the idea a little bit. So what is a function? And just to save some time, I wrote it already here. Function is simply a rule for a relationship between an input, or also called the independent quantity or variable, and the output, or the dependent quantity or variable, in which, and that's the important part, each input uniquely determines one and only one output value. So that's the idea of, there could be relations between, relations or relationships between quantities that don't satisfy this extra condition. So a function is really just a specific kind of a relation between two quantities, so that for every input there is only one and only one output, okay? And then we say that that output is the function of the input. Now, we have better names for all the inputs and all the outputs. So we call, as you might recall, the domain the set of all possible input values to the function, right? So whatever you're plugging into a function is called the domain. And then the range is the set of all possible output values of a function. Okay, so just to reiterate, here I wrote a function, which you have seen definitely before. If you might remember, this here is a linear function. And the reason why this is a linear function is because the exponent to the x variable is just 1. That's what makes the function linear. So I'm sure you remember all of this. But then what does it mean to have some inputs and some outputs, and what does this? And this function, by the way, is written in what we would call function notation. And the function notation simply says just that, right? F of x. So in other words, what? For every x value that you're going to plug in, the output is a function of this x, right, that we're plugging in. And so the output is going to be whatever you obtain by plugging in this x value. So one way of finding the inputs and the outputs is to make yourself a table of values. So here are all the x's, which are your domain, yes? So these are the input values. And then f of x, which many times we also call y, right, is your range, right? So the y values, they come out the output. So what do? We pick a bunch of x's, right? What kind of values are you allowed to plug in for x? So sure enough, every real number can be multiplied by 2 and added 3 to, so you could just pick whatever numbers you want. And as you remember, since this is a linear function, really all you would need is 2 different values for x. So substituting a 0 in here would get us a 3. Substituting a 1 in here, 2 times 1 plus 3 is equal to a 5. You're welcome to plug in one more value here. I'll plug in -1 just for fun. 2 times -1 is -2, plus 3 is a +1, okay? And sure enough, we have plenty more values we can pick for the domain, and they will produce a whole bunch of values in the range. So what we want to do And that's, again, one of the applications in Chapter 2 is going to be graphing functions, much more complicated than this. And so this being a linear function is pretty easy. The point of coordinates, here go the x's, right? Here goes the y, the domain values and the range values. So the point of coordinates 0, 3 is right here. X is 0, y is 3. 1, 5 is up here. -1, +1 is down here. So as you see, the more points we would actually pick, they would all fit on this line, hence linear function. Okay, so this is the graph of this function. On this graph, we put all the possible x and y ordered pairs that satisfy this relationship right here, right? So the x being the domain values we pick, the y's being the range values that come out, right? So the inputs and the outputs. Now, one way, if we look at the domain and the range of this function, what would be the domain? The domain is all the possible x values that you will get, right, if you go along this line. So sure enough, this line stretches all the way left and all the way to the right. So the domain of this function is all real numbers, which this is the notation for all real numbers. And now there would be another talk about what's a real number. This would be all the positive, negative, integers, non-integers, rational, irrational values. The only thing that doesn't fit as a real number is the imaginary units, right? The numbers that have the little I to it. Those are complex numbers. All right. Then what would be the range? The range is all the possible y values that you're going to obtain, right, once you pick any x. So as you see, looking up and down, right, along the y-axis, you will eventually hit every y value, right, because this line is going to go all the way up and all the way down. So the range is also all real numbers. And again, in mathematics, we find many ways of trying to save some time by finding notation. So instead of writing all real numbers, all we do is just write this. This is the symbol again for all real numbers. Now many times, so as you see, for every x value, we will get every input x, right? We will get a y value. You can put 1,522.3, you're gonna get a y value. You can put -5, you're gonna get a y value for this, right? But what this section is really about is what happens if you don't always have a value for an input. So that's the idea of limit that we're going to explore on the next page. So I want you to look at these two graphs I've put up here for you. So as you see, what would be the domain? Okay, I'll just write domain. What will be the domain of this function? In other words, what are the possible x values that we can plug in? So this graph stretches only from an x of what? -3, right? That's the first value in our domain, yes? And by the way, that value is included. So what we do is we put a square bracket for that. And then how far does the domain stretches? It stretches all the way to 2. So this 2 is 2 included in that domain. Do you have a y value for that 2? In other words, can you even plug in a 2 into this function? As you see, you don't. So the parentheses means simply, just as I said here, is that the x values are greater than or equal to -3, but they're only less than 2. So it only goes close to 2. Now, this might be an idea that we're exploring. Well, great, fine. I cannot plug in a 2 value for x because, as you see, it's missing. But could I at least be able to tell what happens close to this value 2? So that's exactly what we'll be exploring in this section. That fine, I'm not going to get a y value here because that's not even part of the domain, the possible inputs for this function. But all I could tell you is that the closer and closer the x values will get to 2, the closer and closer the y values will get to what? The answer would be 0, yes? So the points right here, if you were to take and write down the ordered pairs that I'm encountering on this graph here, on this function, right? This point here is maybe a 1. I'd say 8-ish, right? Then the y is 1. If I get even closer, maybe at 1.9, I might have a 0.5 for y, yes? Maybe if I'm getting even closer to 2, let's say a 1.999, how much closer, what would, because again, the only thing I can plug in is a 2, yes? So I can even zoom that in. Oops. So as you see, I just can't plug in 2, but this graph is going to go closer and closer and closer to it. So as I get closer and closer, the y values here are going to get closer and closer to what? Maybe 0, right? 0.01, I'm not sure. I'm just making up these values, but I kind of see that that could be true, right? Okay. All right. And just for completion purposes, that's what we'll be talking about in a bit. But could you tell me what's the range of this function? The range is the possible y values covered by this graph, yes? So what's going to be the range of this function? What y values are covered? So as I see, my graph starts down. When you write an interval, you always have to start with the lowest possible value to the highest possible value. So there you go. And then the -5 is the lowest y, up to the highest possible y is a 4. And it looks like they're both included, right? So that simply means that your outputs cover any y value. So in other words, if I were to, if I were to write all the ordered pairs on this graph, those ordered pairs will have y coordinates, right? They range all the way from a -5 to a +4 included, right? So even though, yes, on this end, I'm not getting close to 0, but 0 is included on this end, right? So I do get a y of 0. And then there's another one I want to bring up. And then by the end of the chapter, or this section, I should say, we're going to get back to this. So, that's something funny is happening here. So clearly what I'm looking at is what happens when x is 0, right? Now, exactly when x is 0, y is 0. Why? Because as you see, it's bubbled in, yes? So I am producing, not like here with an open circle, there is a y value for an x of 0. So if you're looking on this graph and you're plugging in 0 for x, this function is going to produce a 0 for y, right? Because that's an ordered pair on the graph of this function. But what I'm looking at is what happens to the left of this 0. And as you see, there's almost like a gap, except for what? These values are going to get closer and closer and closer and closer, right? To a -0.0000001, right? And even closer than -0.0000001. I don't know how many O's I've said, but what we're saying is we're getting closer and closer. So what do you think would be a domain? What are x values are covered here even? So see how the arrow is here? That means this graph is going to go all the way down to -infinity. Now, even though there seems to be a gap, they are all covered here. You can get as close as you can to this line. So this line won't quite touch it, but it will just get so super close. So you can put in any x value you want to the left of this y-axis, and it will hit the graph eventually somewhere down below, right? So those values are covered. 0 is covered. We do have a y value for that. And all the way to +infinity. Yes. And by the way, the same thing goes for the range. So, by the way, that's another way of writing all real numbers. You can say all the way from -infinity to +infinity, everything included. So yeah, again, these are all the possible y's. I'm sorry, these are all the possible y's. They go all the way down to -infinity. It gets closer and closer here all the way. It picks up at 0, and then slowly but surely it's going to go all the way up to +infinity. So What we are looking at, or what we'll be looking at this semester quite a bit, is behavior of graphs. And clues on what is going to happen to the graph. In other words, by the way, this graph is increasing here. It's decreasing on this part. As you see, the graph goes up. That means increasing, decreasing, and so on. And whether or not we can tell what happens at every point of the domain to the graph or to the function. Yes, in other words, what sort of outputs does it produce, right? So I hope this was a good review. If you need more, please look back on your algebra classes, and we will continue on the next video.